I was asked to review a facility design last week that contained 5 flower rooms. And since that's far from ideal, that prompted me to make this video, which is really to help you understand the ideal number of flower rooms in a given facility. The common mistake I see that facility designers and architects make is basically creating the maximum amount of flowering canopy in a given facility, because the logic goes that we're going to be there for creating the maximum amount of revenue for a given company or given facility, but it's not that simple. In order to be as maximally efficient and thereby maximally profitable as we possibly can in a commercial cultivation facility, all of our rooms have to be designed proportionally, both upstream and then downstream. Upstream from mother propagation, veg into flower, and downstream from flower to drying, curing, trimming, packaging, and so forth. Because if we're, let's just say, for example, we're harvesting 100 pounds of flower in a given flower room, but we only have the capacity to dry 50 pounds of that, what do we do with the rest? So you could see that everything has its place in the process, and if we're not fully supporting the flower rooms both on the upstream side and then on the downstream side, we're going to create a bottleneck at some point. And bottlenecks almost always deteriorate profitability and create some problems somewhere else in the operation. So let's look at a couple of different examples and figure out how many flower rooms is ideal for a given facility. In order to do that, we have to answer quite a few different operational questions so that we can then design the facility around that. Those questions are, how many weeks are we planning to flower for? Are we going to allow the plants themselves to dictate how long we flower for? Or are we going to select genetics that really determine or really match the design that we have designed for? Are we going to have every single room be exactly the same? Or are we going to have rooms of different sizes? Is every room itself going to flower for the exact length of time, or are we going to have mixed flowering times? At what plant density are we going to plant at? And then what is the average yield that we expect to get so that we can measure what we're going to have downstream, what type of biomass we're going to have downstream to then process? All of those questions really must be supported by the financial model that is driving all of this. So in order to determine the right number of flower rooms, let's answer some of these questions so that we have a good example to go on. Let's say that we're going to flower for what's somewhat of an industry standard. We're going to flower for 8 weeks. We're going to have all of our rooms be the exact same size because in this ideal example, we're building a fresh facility from the ground up. We're going to choose only genetics that match what we've designed for, which means they're going to finish flowering in 8 weeks. We're going to plant at a density of 1 plant per square foot, and we're expecting roughly 80 grams per square foot of average yield. And yes, this is what the financial model dictates for us to do. In this example, and in most other examples, the right number of flower rooms is a multiple of the number of weeks that you're going to flower for. So in an 8-week flowering facility, it's super simple if we have 8 flower rooms. We could also have 4, we could have 16 if the facility is a little larger. And if we have a very large facility, I recommend having blocks of those multiples, whether it be a block of 4 or a block of 8, and then having some redundancy in the facility that essentially, one veg room supports this number of flower rooms, and we just have, farm units or farm blocks that are multiples of one another. What this does is enables us to have maximal operational flow from the start of the process through the end of the process. And really what this will operationally look like, in order to get started, we'll design a production calendar that we are initially planting our flower rooms 1 week apart. Since we're flowering for 8 weeks, we have 8 flower rooms. We're going to start on week 1 and plant 1 room. A week later, we'll plant the next one, and so on until we get to the end of 8 weeks. When all of our flower rooms are now planted, we will then start harvesting the first flower room that we planted. What this really enables is that your staff will really be able to get into a flow and see that, let's call it every Thursday, we harvest a room, and then every Friday we replant that room. That will be on a rinse and repeat schedule indefinitely, so long as no catastrophic failure happens. But it really maximizes the flow of your team and really cuts down on the possibility of confusion, not understanding what step in the process we're going through, and ultimately makes it very easy for financial projections, for supply chain challenges, or just being able to make sure that the supply chain is completely consistent. And it also enables us to make sure that every room in our facility is maximally efficient. So ideally here, the right number of flower rooms is a multiple of the number of weeks that you're going to flower. Let's take it a step further and look at both upstream and then downstream. For example, if we're going to have 8 flower rooms, how many veg rooms do we need to support that? We then have to ask ourselves a couple of more questions. Since we know what we're going to be planting at, what density we're planting at in flower, how big do we want those plants to be going into flower? That will really help us determine how many weeks we need to veg for, and how many weeks we need to veg for will help us determine how dense we can plant in veg. And all of these things will be determined upon the type of end product that we're trying to create for our consumer. So again, let's use another example to make this easy. Let's say that all of our rooms in flower and in veg are all the same size. They all have an easy 1,000 square feet of canopy. And we're going to, like I said, we're planting in flower, we're planting at 1 plant per square foot. And in order to have a decent sized plant, one that's not too small but not too big, that's going to be able to fill that canopy, let's say that we're going to veg for 2 weeks. So in that veg room, we have 1,000 square feet of canopy. And in order to maximally produce, we're going to be able to have, let's say, 2,000 plants in that veg room, because we're going to plant the veg room at 2 plants per square foot. When they go in, they're significantly smaller. When they come out, they don't need to be that big. And in 2 weeks, they'll almost double in size in that regard. And so we'll be able to take and we'll plant that veg room operationally 1 week apart. So we'll plant on, let's call it week 1. We put in 1,000 plants from our propagation in our mother area. We're going to let those plants age for 2 weeks. And on the beginning of that second week, we're going to take another 1,000 plants and put it into the veg room, so that we now have 2,000 plants in veg that are separated in age by 1 week. At the end of that 2 weeks, that first set of 1,000 plants will be ready to move into flower. And then we'll, at the same time, once we move those plants from veg into flower, we will then take another 1,000 cuttings from the propagation room and move those into veg. And so long as this process never stops, we will always have 1,000 plants for each week for our new flower room, the ones that is getting harvested on Thursday, and we're going to replant it on Friday. This becomes a completely fluid system, and in this regard, we really only need 1 veg room to fill all 8 of those flower rooms. And now whether we want only 1 veg room to do that, that's a whole nother question for another video or another article, where we talk about redundancy and how to properly manage risk. Because as you can imagine, if we have only 1 veg room, we have some sort of pest or contamination issue, we don't want to run the risk of potentially not being able to fill any or all of our flower rooms. Now let's look downstream. We just looked upstream, let's look downstream. If we were going to be taking that flower room at 1,000 square feet and are planning to yield an average of 80 grams per square foot, that turns into 80,000 grams of biomass coming down each week, which is the equivalent of roughly 176 pounds. And so from there, we can make the decision as to how large our dry room has to be, at what style are we going to be drying, whether it's on just stable racks or whether we're going to be using some sort of lifting system where we're maximally using the volume of the dry room. But really, we can design 1 or 2 dry rooms to make sure that we have enough space to dry that 175 to maybe 200 pounds of biomass on a weekly basis. From there, we can size the trimming room, the curing room, the packaging room, and so on. And we can also select the right equipment to make sure that it can handle 175 to 200 pounds of dried flower each week. And then we also have the labor to do so. As you can see, all of these rooms should be proportional to one another, and that all should really be designed based on the financial model, which then drives the operational design. And then all of those things in total should really inform how we then design our facility. You'll notice that I asked quite a few different questions. I really am just scratching the surface. This is just for illustration purposes. There are dozens more questions to really be answered in order to maximally and efficiently design that operation to the best of our ability. And more importantly, that is really in an ideal world when we're building a facility from the ground up and having a fresh build to suit. That's exactly how we want it to be. Most of the time in cannabis, because the way that the laws are written, we've had to select a facility that already exists. It might be in a less than ideal area. It might be less than an ideal condition. It might be 50 or 75 years old and really be in need of rehab. It's unlikely to be that perfect box that is something that we can then subdivide and make look exactly like we want to. So there's often many, many dozens of concessions that we need to make in order to fit that ideal operational design into the facility that we have. And we have that facility for lots of reasons, whether that was the one we could afford, or in most states, that was the one that was available in the location that we had, so that we can really take that opportunity that is very few and far between and turn it into as maximally profitable of an operation as we possibly can. Hope this was helpful. If you guys have any questions that I can further elaborate on, please leave them in the comments. I'd be happy to take care of and answer them further.